Hello, in this video we are going to study about subsets and universal set. A set A is said to be a subset of a set B if every element of A is also an element of B. The symbols, this means is a subset of or is contained in. This means is not a subset of. This symbols means implies. This symbols means IFF means if and only if. The mathematical representation can be described as A is a subset of B if element A belongs to set A implies that element A belongs to subset B. A set is always a subset of itself. Phi, which is a null set, is a subset of every set as it has no element in it. Let us now move to the definitions of proper subset, superset, singleton set. If A belongs to if A is a subset of B and A is not equal to B, then, for example, if we consider A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, then A is a proper subset of B and set B is a superset of set A. By singleton set we mean that it has only one element. So if set C has only one element, let us say 1, then it is a singleton set. Moving on, let us solve some questions based on the theory we studied above. Consider the sets phi A equal to 1, 3, B equal to 1, 5, 9, C equal to 1, 3, 5, 7, 9. Insert the symbol is a subset of or is not a subset of between each of the following pair of sets. Phi is a subset of B because phi is a subset of every set, so we can write it that way. A, which is 1, 3 and B 1, 5, 9. We can see that 1 is common to both A and B. So A is not a subset of B. As the element 3 does not belongs to B, next A is a subset of C as 1 and 3 are included in C. B is a subset of C as 1, 5, 9 are included in C. Let A, B and C be three sets. If set A belongs to set B and B is a subset of C, is it true that set A is a subset of C? If not, give an example. Let A equal to 1, B equal to set of A, 2 and C equal to set of A, 2, 3. So we can simply see here that if A belongs to B, that means whole of A, that is the set A belongs to set B, and B is a subset of C, so that means every element of B is in set C. So one set of A, that is set of 1 comma 2, are in C, as we can see here. But if we see that element 1 is not individually in C, so that's why we can say that A does not belongs to C. Note that an element of a set can never be a subset of itself. Let set S is equal to 1, 2, 3. In this context, we can see that 1 is an element of S, but 1 itself is not a subset of S. Set 1 is a subset of S, but set 1 is not an element of S. Subsets of set are real numbers. We can see that set of natural numbers is a subset of set of integers, which in turn is a subset of rational numbers, and rational numbers are a subset of real numbers. Here T means irrational numbers, which is a subset of real numbers. And we can see natural numbers is not a subset of irrational numbers. Intervals as subsets of R. Let A, B belong to R and A less than B. Then we can represent A, B as set of all x such that x is between A, B. This is called open interval. And if we try to look it on the number line, we can see it as A, B. Similarly, we can see closed interval A, B, closed interval as length of any of the intervals is, as you can see from the representation on the number line, B minus A. Moving on to the last part of this video, which is the definition of universal set. The universal set in set theory is the set that contains all objects under consideration, typically within a particular context or framework. It is often denoted by capital U, All other sets in that context are considered subsets of the universal set. For example, the set of integers and set of rational numbers. Set of rational numbers can be considered as a universal set for set of integers. Thank you.